9:01, is that right? All right, let's get going here. Oh, that's loud. All right. For your announcements, hand in assignment 0 at the end of class today. We're going to get people to present it today. And I also want you to write on the sheet on your on the hand-in whether you presented it or not, and whether you posted it, and if you posted it first. And if you don't know if you posted it first, don't write that. It's only if you actually looked through them and declared that you posted it first that you should say, I posted this application first. We can check, but it turns out to be a sort of an n-squared operation to check who was first. And if you're on the waiting list, please do assignments. I can't guarantee there are too many people on the waiting list to know what to know what's going to happen with that. All right. Does anyone have any questions about anything? Yeah. Yeah, thanks. So the classes are being recorded. They're put up posted on the website. So if you're presenting something on, I'm going to pass this microphone around, then you'll be on the video. So if you don't want to be your voice to appear on the video, don't volunteer. And also, we're trying not to show anyone's faces about anything. All we're doing is showing on the video is just the screens and what I'm writing on the board. Just that people in the past have said they like that, and so I thought we might as well keep doing that. So if you miss out on something, then you can just review the video. All right, other questions? Yeah.
So for the assignment here, do you prefer to put our student number on there or the student ID on it?
Put your student number on it. I'm just trying to think of how Canvas indexes. So I think Canvas indexes, and that's how we're going to put it into Canvas. I think it does it by student ID. So student ID is the best thing because they're unique. Any other questions? There is assignment 1 that's available. As I said before, we're going to have lots of small assignments. You can do them in groups. They're designed to learn something. Given classes on Tuesday and Thursday, it's a good idea if we have a homework that's due on Monday night, so that so that we all know we've all got what was happening the previous week, so that we can keep up with what's going on. So it's trying to make sure you keep up and you understand what's going on from the previous week. So there are programming assignments. Let us know if something's not working. One of the ones you can use, there's some Python code that's sort of very basic. We tried to write code that was as simple as possible to do all of the programming we're going to do in 3.22. So all the algorithms are all written in Python for you to use. There's a trial version of the web-based Jupyter Notebooks one where there's actually graphs and it's all embedded. This was written by a URSA last summer, and it's the first time we're testing it out, so it's sort of no guarantees. I'm told that the Python code works, but this one here is, we'll show you how this works later on, but there's actually graphs, and you can manipulate graphs and do all sorts of fun things, but it's not, it's still in beta format, but I thought I'd let you play with it if you wanted to. And the other thing to do is, people always want to know about lateness policies. Part of this class is learning about reasoning under uncertainty, and so you get to reason under uncertainty about when you hand in your assignment. I accept it up to the time I post a solution, but I'm not telling you when I'm going to post a solution. It's just I'm not going to post a solution before the due time. Okay, so you get to choose, is he likely to post one at 1 minute past midnight? Well, you get to sort of figure the probability of that out and work out whether you want to submit it late or not. So decision-making under uncertainty in practice. The safe way to do it is just submit things on time. But I'm not going to accept anything after a solution is posted. Right? I can't accept something after a solution is posted. All right, any other questions about anything? All right, let's get back to here. All right. So this is what we did the first time. Last time we looked at this abstraction of agents acting in an environment where you had the abilities were the set of actions that were available to the agent, and as we change the abilities of as you change the set of actions available, you're going to change what the agent does. The goals or preferences of the agent, what the agent wants to achieve or what it prefers about the world. So it's going to act to solve its goals, or it's going to act to maximize its preferences, to give the world the resulting that is best according to its preferences. There's prior knowledge about what it's programmed into it, or in the nature and what evolution has given you, what you can do before you start experiencing the world. And then there's stimuli from the environment, which is both sort of observations and things the environment does to you, because the environment can actually push you and pull you and do all sorts of things to you. And also past experiences, our memory of the environment. And we need the past experiences in order to learn. So if your past experiences are what we're going to use when we actually start learning about the world. So are there any questions about that? Questions? So everyone understands this? Good. So if I give some clicker questions, you'll be happy. You go. All right. So let's go through this. It's A, B. So what's the ability of an agent? We've stalled. Does anyone need more time? Anyone still going? Need more time? Okay. Let's. Oh no. Let's stop. All right. So the answer is the set of actions available to the agent. It's not what functions the agent was able to compute. It's about the set of actions. What actions can you do in the world? That's your abilities in this. In this is what actions can the agent actually do in the world. So it's because as you change to what actions you can do, you can do anything. Nearly all of our actions are Turing complete, and they can compute any functions they want. All right. Questions about that? All right. An agent that does not learn does not need what? Does anyone need more time? Oh, we got more this time. All right. People are waking up. Good. All right, let's stop there. Right. So you don't need to worry about the past experiences if you're not learning. For the role of past experiences in this thing is to actually learn from experience. So if you're not learning, all you're going to do is just react to the world. You just need your observations, your prior knowledge, your goals, and your preferences. So you don't need to worry about your history. You can just react in the world. And so some of the agents that people try to build are very just reactionary, that don't learn and sort of effectively ignore their past experiences. I think sort of Roombas are like this. Right? I think they don't actually learn about your house. Or they didn't used to. They might now. But okay, any questions about that? Okay. All right, let's quit that. All right. Then we talked about all of these dimensions. We talked about whether modularity, whether it was flat, modular, or hierarchical. Most simple systems are flat, but nearly all complex organizations, complex biological systems and complex computer systems are all hierarchical, and sometimes we're going to reason about them flat, and sometimes we're going to reason about hierarchical. There's the planning horizon about whether we're not planning, whether we're finite stage, indefinite stage, or infinite stage. Then there's whether we reason about states explicitly, because a lot of whether we reason in terms of features about the world, where the world's made up of lots of different, where the states are made up of lots of different features, where we can reason about the features separately, or whether we reason about objects and relationships amongst them. Whether we have perfect rationality or bounded rationality, whether we're learning from experience or whether we just pre-programmed everything in, whether we've fully observable means we actually get to observe the state of the world, and partially observable means we just get what's in it, comes out. Our senses don't find out exactly what's true in the world. The effect uncertainty about whether the world's deterministic, whether we can predict the effect of actions or whether we can't predict the effect of actions. And the preferences are either goals or there's complex preferences, and then we had both ordinal and cardinal preferences. Whether they're single agents or multiple agents, and whether the interaction is offline means we can do it before we start interacting with the world, or online we have to reason while we're thinking about the world. Okay, are there any questions about what any of those mean? Or any of them? So as we go through the class, we're going to explore a lot of these dimensions. Any questions about that? Okay, so let's do another click question. All right, let's see what you think. So chess is this game. I want to know whether it's stochastic and partially observable, stochastic and fully observable, deterministic and fully observable. Well, how does it fit in? Who doesn't know chess? Does anyone not know what chess is? There are cultural assumptions here, though. All right, does anyone need more time? Does anyone need more time? Okay, let's stop there. All right. So is it partially observable? Do you get to observe the state of the world? Right, you actually get to observe everything that's on the chessboard is available to you. You can observe the whole state of the world, so it's fully observable. Is it stochastic? Well, there's no randomness involved in it, right? There's, you get to move, and whatever happens, that you get to choose it. So the idea here is that chess is deterministic and fully observable. So in this sense, it's the simplest of all of them. Yeah. Yeah. So what would it then be? So then you think it's B because it's stochastic and fully observed because you're not modeling the other agent. Yeah. Yeah, so in these two-player games, this thing gets a bit tricky because there's multiple agents. Yeah, because there's multiple agents, B is arguable, I agree, yeah.
Would it be deterministic if you have the ability to keep all the possible moves that they would come?
Well, we don't know what they're going to do. So the point of there is the point of the other.
If you predict what he's going to make, wouldn't that can you plan ahead then?
We can plan ahead, but that doesn't mean it's not stochastic. What's happening in the world is I'm going to plan about my trip that's going to be stochastic in the sense that I'm not going to know what the traffic volumes are going to be like or whether I'm going to get traffic lights, but I can still plan ahead even though it's stochastic. So later on, we're going to do, at the end of the class, we're going to do planning even though things are stochastic. Yeah. Yeah, but they don't. I think the reason why I was going to say it was C is because for each person, it's completely, when you do your action, the next state is completely predicted. right? And so each person, for each person, when they do an action, what the resulting state is completely deterministic, right? And that differs from backgammon, where you actually roll a dice, where I don't know when I have to make a move, but I don't know what's going to happen next because I actually end up with rolling a dice. So this backgammon, you actually get to observe the full state of the world, but things randomly happen, right? So backgammon is one of these games where the answer is, it's definitely not. There's dice rolls involved in it. Oh well, we don't need that. All right. Let's. Did I mess something up? All right. So what about poker? For this level of abstraction, I'm guessing they're all the same. You shuffle cards, you deal them out. Just normal poker where you hold hands in your card. Oh no, doesn't matter anyway. Reopen. All right, the classic's not working. Oh well, it's already running. All right. So what's the answer? Do people think? I was going to say it's stochastic and partially observable. Right, you don't get to observe the state of the world. There's all these hidden states of the world, but it also has this random element involved in it. All right, I wonder if I can start. Let's see if I can do this again. Oh, it did work. I shouldn't touch it. So this is software written that UBC bought, so it works much worse than the code written by our URSA last summer. I shouldn't say that. All right. Close. All right, so what's another one? It's about the goals. Sam prefers coffee to tea. What would you think that is? Is that a goal to achieve? Is it an ordinal preference or a cardinal preference? All right, does anyone need more time? Okay, let's stop there. All right, this just has an ordering involved in it. So this is an ordinal preference. It just talks about they prefer this to this. If they say they're prepared to wait an extra 5 minutes, or there's some value they prefer it 10 times as much, it's a cardinal preference. A cardinal preference is where we assign numbers to things. Ordinals are just where things are ordered. So if we have a cardinal preference, if you can talk about how much pain you're in and and you're trading off pain and other things, or you could say, I want coffee to tea, and as long as it's more than 5 minutes longer, and you start adding in costs and things, then it's a cardinal preferences. So at the moment, it's just an orderal preference. It's just ordering. Actually, I'm surprised that people heard this. It's a sort of common mathematical term, ordinal and cardinal. It's a good thing to know anyway. Ordinal is just ordering. Cardinal is where you assign numbers to things. Right? So it's actually useful to know that. You should know it from other things. Any questions about that? Okay. And if we think of Sam wants coffee, what's that to the robot? It's told Sam wants coffee. Oh, good. All right, anyone need more time? It should be easier. Right, so that's an achievement goal. It's something that the robot's now trying to achieve. So it's got these other goals of saying, Sam wants coffee, now we're going to bring it coffee. It's going to be seen as a goal, it's doing it. You could say Sam wants a drink and it prefers coffee to tea, and then you could actually start searching about what the best solution is for this. At the moment, this is just a goal to achieve. Okay, so some of the time we're going to talk about achievement goals. So early on in the class, we're going to talk about achievement goals, just what, we have a goal, and the next one we're going to talk about some preferences over things. All right. So today what we're going to do is we're going to talk about AI applications, in particular assignment 0, and then we're going to talk about graph searching as an abstraction to problems. Lots of problems we're going to start mapping into graph searching problems. All right. So what I want to do is I want you guys to tell us about it. So I'm going to have a microphone here. This should work. All right. Who wants to tell me about an application they did? So I presented lots of them last time. So who wants to tell me about one? Come on. Someone volunteer. I don't want to pick people. Yeah, here.
Oh boy.
Just tell me one thing that's sort of interesting about. Tell me what your application is and one thing that is interesting from it.
So I found an article that was talking about sort of a set of applications which are being worked on in academia, which play the real-time strategy game StarCraft. And I thought that I really was interested in this because of the kind of modeling that it has to do and how it's distinct from other game-playing artificial intelligences that I'm familiar with. Just like in the difference in, if you have like a chess-playing AI, it knows where a whole bunch of discrete states are for pieces. But in a game like StarCraft, there's an infinite number of potential places where a model, a sprite can be in the game, and the game has to reason about all of those states and represent all of them and figure out where things can go and where things can't go. And how they move, and it also has to do reasoning about very, very small level managing and moving individual sprites in the game, and also has to reason about very high level strategic concepts in order to win.
Right, so it has to be hierarchical. It has to be. So is that a problem because it's partially observable or because there are just so many states?
Yeah, it's partially observable because there are so many states, and it's also partially observable because a lot of the game and the actions of the opponent are concealed throughout the game. Increasing your observability of the game is a big part of how the game is played.
All right. Thank you. All right. Someone else wants to. Yeah. Someone up there. Stick their hand up. Here.
Hi.
Is it on? Should be on.
Hello. So my application is Forza's Drivatar adaptive AI system. And what it does is that it creates AI racers that mimic real users to incorporate their driving styles and even the mistakes that they make to appear more realistic and give players an unpredictable experience. What I found interesting about this technology is that players can actually troll the system because it's actually not smart enough to realize that if a lot of players drive a certain way, like say they just spin donuts throughout the entire game, then the AI isn't actually smart enough to figure out that that's not a regular driving style and they shouldn't copy it, but it will anyways.
All right. Anyway, who else? You pass it down to that person.
Well, the application that interests me a lot is Face++. It's actually a startup created by a Chinese entrepreneur. Basically, what it does is to do face detection and face comparing by a bunch of smart algorithms. For example, one application that one of the most popular applications is that you can unlock your phone or make a payment by scanning your face. Furthermore, when we just imagine that when we arrive a new country, for example, I arrived Vancouver 2 weeks ago. I need to go to the kiosk and scan my face and comparing the living photo with my passport ID. So that is big application. The other one is that for most iPhone users, especially for iPhone 10, it can track users' expressions and use them to animate their favorite emojis. That is very interesting. Yeah.
All right.
Thank you.
Good, thank you. Anyone else want? Who else wants to present something? Tell me something. Yep, can you pass it up to?
There we go. So mine, the paper that I read, which is not a fielded or it was purely a research process, but basically what they did was they created a game that had a number of agents, all of which had the same sort of basic AI structure, and a number of landmarks. And then for each agent that was in the game, it was given a goal. And the goal would be something of the format, I want agent X to look at landmark Y. And so each of the agents then had sort of like 3 actions. They were able to move, they were able to look in a particular direction, and they were also able to chat or like sort of communicate. And they had sort of a basic list of symbols, but the symbols were sort of given no meaning. And otherwise, they didn't really have much else. They had the ability to, obviously, while they're looking, and they can sort of observe. Each agent was able to observe like what all of the other agents were saying, but they weren't able. It's a silk. There we go. But they weren't able to actually observe like the positions of the other agents. And the idea is that essentially the agents, in order to achieve their goals, would have to learn to communicate using the symbols. And so when they sort of generated and played this game, the agents would chat. They'd sort of start making these symbols and sort of create their own language and learn to communicate between each other so that they would all be able to achieve their goals of like getting another agent to look at something in particular.
All right. Someone else? Okay. You can pass it across, please. It's easy to me running. Or if someone wants to speak on the way when they hold the microphone.
I just yell.
Oh, you can yell. Oh, but then when it's on the mic thing, we might as well.
Yeah, hello. So the AI application that I researched was it was developed by a company called OpenAI, which is like a non-for-profit, non-for-profit company, and it is co-founded by Elon Musk. And this company made a bot for a video game called Dota 2, which is esports game. It's in this case, it was just like the 1v1 context. And the thing that I found particularly interesting about this is that the prior knowledge that the agent or the AI had was nothing pertinent to strategy. It just kind of was given sort of logic and how to move about the map or the environment and sort of how to move and you know how to purchase new items, things like this. But strategies were not pre-installed, and it was all learned, and it was learned over time by competing with itself. And over time, the interesting observation is that some of the strategies that it developed were a lot of them were strategies that player use. So this tactic of kiting, where you're sort of you're using range attacks and you're keeping your enemy sort of at a distance and moving backwards, retreating, whilst at the same time still attacking them, is something that a lot of players use, but it wasn't pre-installed in the AI. So it learned that over time. I thought that was really cool. And in the end, it was able to, in the fall, was able just after a few weeks to defeat professionals on like a world stage. So that was interesting.
All right, someone else who doesn't have a game.
Sorry.
That's okay. Someone had that here. Sorry.
So I did something called Clue, that's spelled QLOO, and basically what it does is it's sort of like Netflix and Spotify, but for everything. So it spans across books, fashion, restaurants, TV, nightlife, sports, people, travel. It brands itself as the cultural AI. So basically what it does is it establishes relationships between items in the context of consumer taste. And what makes it really cool is that unlike Netflix and Spotify, this AI will actually develop mappings across different data domains. So for instance, it could predict that people who like the film The Grand Budapest Hotel will tend to also like the music group Mumford and Sons. So it's a fielded system. It's been collecting real-world open source data for over half a decade. Just to illustrate its scope, it's been analyzing and compiling statistics in over 2.7 million restaurants, 1.3 million apps, podcasts, or games, and 85 million consumer products. There's currently a Clue iOS app, but it's more so the team is focusing on providing their API to businesses for them to develop marketing campaigns that better understand their target demographic. And so far, it's been used by Twitter, Pepsi, and BMW, just to name a couple of those. And it uses neuroaesthetics research and machine learning algorithms and neural networks.
All right. Someone else? Here.
I researched a application called Cogito, which is marketed towards call center agencies to train their agents. And so basically it is a software that runs real time and runs while you're having a conversation between an agent and the customer. And it analyzes the conversation and gives suggestions to the agent whether to slow down or to like change tone, or if they're interrupting too much in order to improve customer experience. And it also predicts how the customer is engaged in the conversation in like real time. So, and it's a pretty cool application in that it is able to predict and understand human behavior better than the agent, him or herself, who is human. So I found it really cool.
All right. Who else wants to tell us about something? Come on, someone should. Yeah, thank you.
So I found this software called Juke Deck, and what it does is it composes music and creates like melodies or whatever that can be used for creative projects. So once the users input things such as mood, style, length of tracks, and etc., stuff like that, it just generates music like randomly. And so what I found interesting about this software is that